Hello everyone and welcome to the YouTube channel of BeingACCA. This is Tushita Gupta, ACCA affiliate, and in this video we are going to be solving questions from investment appraisal. So this video consists of two questions from this topic. First is Bell Company and the second question that we will be doing is Care Company. The further questions will be solved in the videos that follow this video. Okay, so let's first begin with Bell Company. Let's read the question. Bell Company has decentralized and divisional managers are allowed to make their own investment decisions subject to confirmation by the main company board. Because each of the three divisions, Ding, Dong and Merrily, are subject to different levels of risk, it has been thought appropriate to use different discount rates in each division. Ding has been told that its real discount rate is 5%. The general rate of inflation based on an index that uses very wide range of prices is 2%. In the industry in which Ding operates, a number of prices are seen to be inflating at 3%. Dong is assessing a project in which the first of four annual lease payments has been agreed at 120,000. This is payable in 1 year's time and subsequent payments will rise by 4% per year. Dong's proper money cost of capital is 8%. Moving to the next one, Merrily is considered investing $1 million in a project which will produce the following annual outflows and inflows. Okay, so these are the inflows and outflows given to us. The cash flows which arise at the end of each year are stated in current year terms. It is expected that the outflows will rise by 3% per year and inflows by 2% per year. The money cost of capital of Merrily division is 9%. Okay, so let's see what the first question asks us. The first question asks what is Ding's money discount rate. Okay, so we have information given about the real discount rate, the general inflation rate and the specific inflation rate in the industry. We need to find out the money discount rate. Now first of all, the formula that we have is 1 plus money rate equals to 1 plus real rate multiplied by 1 plus your general rate of inflation. Right? Then let's put the values in this formula. We need to find our money rate only. So this is 1 plus, what is our real rate? Real rate is 5%. And then multiplying this by 1 plus the general inflation rate, which is 2%. Mind it that the 3% specific inflation rate has been given just to confuse you over here, and this has nothing to do with what your answer has to be, and we will subtract 1 from this to find out our actual money discount rate, which comes out to be 7.1%. So I will just highlight as this is my correct answer. Moving on to the next one, what is the present value of Dong's last payment that will be made in 4 years time to the nearest $1,000? Okay, so the second question wants me to calculate the present value of the fourth payment. So the first payment is mentioned that we will give in 1 year's time. So 1 year's time, 2 years time, 3 years time and 4 years time. It is mentioned that the first payment is going to be 120,000, and what we will do is this payment is going to be inflating at 4% per year. So after this will be 1.04 in the second year. Similarly, this will apply for all of the remaining years as well. So in the fourth year, I'm going to be making a payment of, just a second, I'm going to be making a payment of this much in the fourth year, and now this I have to discount to the present value. So I can just use the discount factor, or I can discount it using the formula that I know, and which will come out to be 1.08 raised to the power of minus, I'm just dividing it, so this is raised to the power 4 because I'm going to bring it to present value. This is at the end of fourth year and I want it today, so this will be 99,000 and we want it to the nearest 1,000, so 200, this will be rounded down and we will write 99,000 over here. Let me put a text box. Right, so this will be 99,000 is already given, so I will not write that. Okay, what is the NPV of Merrily's project to the nearest $1,000? Okay, so this is the project of merrily that is given to us. First, let us net out these cash inflows and outflows. We have a time horizon of 3 years, right? And we have our initial investment of $1 million. Initial is 1 million, right? And then we have these inflows and outflows that are given to us. So it is also mentioned that these are not inflated according to the these are in current year terms, and these will have to be inflated according to the rates that are given to us. Outflows by 3% and inflows by 2% per year. So this means, first of all, let me write my inflows and then let me write my outflows. Okay, so first of all, the inflows that I have is first inflow is 2000. So this will be 2000 multiplied by inflows, the rate is 2%. So this will be 1.02, my bad, and raising it to the power of the year in which it is being that it is coming in. Then again, for the next year, this is 3000 and this is 1.02, raising to the power of the year that it is coming in here. And we have the last inflow as 1000, and I will just raise it to the power of 3 because it is coming in the third year. With this, we have all our inflows that we will be getting. Now let's come to the outflows. So as for the outflows, I have this will be negative 1800,000, and then multiplying this by 1.03 because 3% is the rate given for outflows, right? And again, similarly, minus 2500, 123, and raising it to the power 1.03 raised to the power 2. And then again, for the last year, minus 1500,000 and raising it to the power 3, right? And we're done with this portion over here. Let's find out the net inflows that we'll have. We'll just add these, sum of these two, and we'll have our, apologies, so this is the sum of these two values, and just copying this over here and maybe over here also. So we have no, okay, let's put it like this. And now we can find out the NPV. This will come out to be, the rate that we're supposed to be using is the money cost of capital, which is 9% for this particular division. So 9% is the rate that I'm going to feed in Excel. These are my inflows slash outflows, the net inflows rather, and then I'm just going to add the initial outflow. This will have to be formatted in currency, and with this we have our answer as negative. Okay, this does not seem to be an option. Let's first find out whether we did any mistake. Oh yes, we did forget a 0 over here. And now we have come to the right answer, which is 61,436, and to the nearest value will be this, the option D. So this is my answer. Moving to the next one. When considering risk in project appraisal, what is the main advantage of using simulations to assess the appraisal? So when you are using simulations, what will be the advantage, the main advantage? A clear decision rule? No, there is actually no rule with simulations. It is just getting to know your project better. In a simulation, you can change your variables and see what will change, if what changes will bring how will they impact your project. So yeah, then let's go to the second one. More than one variable can change at a time. This is very much an advantage that simulations offer. Statistically more accurate? No, this may or may not be true. The variables that you enter and the data that it produces, these are just the estimates. And being diagrammatic is easier to understand. But this may always not be the case. However, the advantage that is given in statement B is one of the most concrete main advantages of simulations, that you can change more than one variable at one time. Now, moving on to the last question for this. Is it possible to have a negative real discount rate to apply to the cash flow estimates made in current terms when making investment decisions? From the below, select yes or no and then select your reason. So, first, let's find out whether this is possible. So, this is the fifth question, and they are asking if the negative real discount rate can be negative, if the real discount rate can be negative. So let's see. The formula that we had over here was this. Let me copy this here. Right. So when will we have a negative real rate? So see, the money rate, let's take an example. Let's suppose your money rate is 4%. So that means the left hand side of your formula becomes 1.04, right? And then real rate, let's assume we are taking it to be X. We do not know it right now. And let's suppose the general inflation rate is more. The general inflation rate is, let's suppose, 5%, which will make this figure over here 1.05. Now, if I have to find real rate, I'm going to take general inflation rate over this side, and it is in multiplication over here, and here it will be divided. So if I perform this calculation, I will have this as my answer. 1 plus real rate is this, and if I find out my real rate from this, I will have this will be -1 to find out the real rate, and again this will come out to be negative. So yeah, it is possible to have a negative real discount rate. And when will this be possible? We have our money rate as 4% and inflation is more than that, which is 5%. So this is this option. It will happen if the rate of inflation exceeds the money cost of capital. So with this, we have come to an end to this question. Let's move to the next one. Care company. Care company needs to replace a major piece of office equipment that is in constant use and for which there is expected to continue to be used for the foreseeable future. Two types of machines are available with different capital costs, useful lives, scrap values, and annual running cost. Machine 1 will initially have a life of 4 years, scrap value 60,000, annual running cost 72,000. Machine 2, initial cost, life, scrap value, annual running cost. Okay, the cost of capital that is given to us is 10%. Assume all cash flows except the initial capital cost occur at the end of the relevant year, and assume taxation and inflation can be ignored. Now, the first question wants us to find out the equivalent annual cost of machine 2. Okay, so let's come over here. This is the question, care company. This is the first requirement over here, and we have to find out the equivalent annual cost for machine 2. So let's first find out what are the variables that we need to look at. So let's first find out the NPV for this machine. So we have a negative 540,000 initial investment. 540,000 initial investment. So this happens at year 0, and then we have a life of 3 years, scrap value of 120,000. So 1, 2 and 3, I have at the end of the third year I will have a scrap value of 120,000, and then annual running costs are of 47,000. So that means let me write my annual running cost over here. This is minus 47,000 and again minus 47,000 and again minus 47,000. And since this is a machine is an expenditure, we have our initial expenditure, we have annual running costs, so the entire NPV that we'll get will be a negative figure. And then when we are comparing which machine to opt for, we will see that whichever has a lower negative figure will be more beneficial for us. So let's sum these up so that we get a net answer. So the sum of these will be this, and then let me find out the NPV over here. NPV will come out to be the cost of capital that is given to us is 10%. So 10% is the rate that I'm going to feed. These are the three inflows and outflows, and then I'm going to add my initial outflow. And with this, I have my NPV. Okay, let me put it to currency terms. Right, so this is our NPV and it is a negative figure. Why? Because it is a machine, and the machine also has initial costs, and we are dealing with it in the terms of annual running costs. So it has a negative NPV. Right, so let's see the equal annual cost. So the equal annual cost is nothing but something that we discounted to today's time with the annuity factor. So the annuity factor we will use for 10%, and for how many years we will use it for 3 years, because that is the useful life of this machine. So the annuity factor given to me in the annuity table is 2.487, and if I just divide this by this, I will have my equal annual cost, and my equal annual cost will come out to be 227,874. And if I just round this off, I will bring it to a higher thousand, because the value is in 874. So this will be 228, and 1000 is already given over here. So I will enter 228. Now moving to the next one, drag and drop the relevant statements to indicate whether they are true or false. The equivalent annual cost calculation assumes the same type of machine is going to be used for the foreseeable future. Now this is true because this method has one of the assumptions that whichever assets that we are evaluating will be replaced in perpetuity, or at least in the foreseeable future. Then moving to the second statement, the equivalent annual cost calculation assumes the capabilities of machine 1 and machine 2 are identical. Okay, so one of the assumptions that this statement is also true. Why? Because the assumptions that we take in the EAC calculations, it is one of the basic assumptions that whenever we are evaluating two machines, their efficiencies, their operating efficiencies will be similar. So both these statements are true. Moving to the next one, it is now felt that the final scrap value of the machines depends on two factors: whether or not a new supplier enters the market, the which would reduce the likely scrap value, and the strength of the dollar against other currencies, since the sales of used machines will be made abroad and invoiced in foreign currency. Adverse effects will each reduce the scrap value by 10% of the figure used in the investment appraisal. The relevant probabilities are given to us. Okay, so the scrap value that we had for machine 2 was $120,000, and we have some probabilities and some possibilities given to us which can potentially reduce the scrap value. Now this question wants us to find out what is now the expected value of the scrap proceeds from machine 2. So let's find that out. See, here we will have to be very careful with the calculations that we do for probabilities, because we will also have to account for joint probability in one case. Joint probability is nothing where two things will happen at the same time, and their individual probabilities we'll have to add together so that we get the total probability. Okay, and we will also have to multiply probabilities sometimes, because these are instances at which one probability will affect the other probability also. So let's find out what is the value for the expected value of the scrap proceed. So in the first scenario, let's label our headings first. So this is the scrap value. We will write we will write over here the probability, and then in this column maybe we can write there expected values, right? So in the first scenario, when we are getting 120,000, this will only be possible when the new supplier is actually not entering the market and the probability is not strong. So it will depend on two factors, that supplier does not enter and dollar does not get strong. So this is 0.6 multiplied by 0.7. So this is actually the probability that I have, and this is the expected value that I will be getting from this machine. scrap value of this machine. Now in the next scenario, the scrap value will reduce by 10%, so it will be 90% of this value, right? So this makes it 108,000. Now when will this happen? This will first of all happen when the supplier enters the market. So there is a new supplier, and the probability of a new supplier entering is 0.4, and this we will multiply with how much? 0.7, that your dollar does not remain strong. So this is the first case when we will be able to solve, when we will be able to sell for $108,000. And there is another case when we'll be able to sell it at $108,000. When is that? That is when the new supplier does not enter, but your dollar becomes stronger. So this will be 0.6 multiplied by 0.3 when your dollar becomes stronger. So there are two possibilities. I could have separated both of them. I could have taken these separately. I could have written 108 over here and just let it be 0.4 multiplied by 0.7, and in the next cell I would have written 108,000 again over here and would have taken 0.6 multiplied by 0.3. Both of these methods are absolutely correct. So I will just drag this over here because the formula is already put. So this is the expected value if it is selling for 108,000. Now let's assume both of these possibilities go against our favor. There is a new supplier and dollar also becomes strong. So what will happen then? Our probability, the scrap value will even reduce by 10% more. So this will become 80% of this. So what will be the probability in that case? There is a new supplier entering, which is 0.4, and then there is also the dollar getting stronger, which is 0.3. So with this we will get an expected value of this much, and if I just total these up, I will get my total expected value, which will be my final answer. So this comes out to be 111,600. Option C is my answer. Right. Now moving on to the next one. To overcome the difficulties of incorporating probabilities into the investment appraisal calculations, Care Company could perform a simulation exercise to help reach a decision. Drag and drop to indicate whether the following statements relating to simulation are true or false. Now let's read the first one. It eliminates the effects of risk associated with various estimates. No, not at all. It will only tell you that how will a change in something affect your project, but it will not eliminate the risk associated with the estimates that you are putting in. So the first statement is false. Moving to the second one, it requires probabilities of estimates subject to risk to be known. Yes, this is absolutely true, because when you are doing a simulation, the simulation will actually require you to enter probabilities, and this will be subject to the risk to be known. Right. Now moving to the last one, which of the following statements about Care Company's replacement decision are true? Let's read the statements. The decision between machine 1 and machine 2 could be found by calculating the total NPV of each machine over a 12-year period. Now let's find out. So these machines, for machine 1 it will be 4 years and machine 2 has a life of 3 years. So that means it is not a like with like comparison, because for machine 1 we will be considering 4 years and for machine 2 we will be considering 3 years. So it is not fair because the values will not be a like to like comparison. So what we'll do in this case is we will try to find an LCM. So what we'll do, the LCM of 4 and 3, the LCM of 4 and 3 will come out to be 4 multiplied by 3, which is 12, and this is how we will have a like with like comparison. We will find out the NPV for 12 years for machine 1. This will be simply taken for 12 years consecutively, and machine 2 also for 12 years, so that we do have a like with like comparison. This means statement 1 is definitely true. Moving to the second statement, the replacement analysis model assumes that Care Company replaces like with like each time it needs to replace an existing asset. yes, this is definitely one of the assumptions that we use in this model, and this statement is also true, which makes option B the right answer. With this, we have come to an end to this video. In the next video, we will be solving the following two questions. The first question is Easter Company, and the next question will be Ace Company. Stay tuned for the next one. Thank you for